Okay, so this is our first video solution guide to the POW for Block 2. I'm going to ask your patience and forgiveness as I figure out how to keep the camera steady. This is not going to be very pretty or high quality, but Hollywood was never in my future anyway. Alright, so today we are talking about alternative algorithms for addition. So it turns out that both of these algorithms are actually valid, and we're gonna solve this one here, 47. We're gonna use the expanded version and figure out why it works. So I'm just gonna walk through it. So when I add 4 ones and 7 ones, I get a total of 11 ones. And in the expanded algorithm, we don't do any regrouping right away. We just go ahead and write how many ones we have. Well, we have 11 ones, which is actually a group of 10 and 1 extra 1. So then when I add 90 plus 40, 90, 100, 110, 120, 130, I can write that down. This is a partial sum. So it's a sum, but of only part of the numbers. And then how many hundreds do I have? I still have a total of 8 hundreds. And then I can add all of those partial sums together. So I only have 1 1, I have 4 tens, and I have 9 hundreds, and I get 941. Which is the same thing I get if I add 894 plus 47. So how many ones do I have total? Well, I only have 1 1 because the second one I'm going to add to my tens place. I'm going to go ahead and turn this one from 11 into a 10, and I'm going to wait to add it until I know how many total tens I have. Well, I have 9, 10 tens, that's going to be a new 100. 10 plus 4 is 14, so I have 14 tens. Well, 14 tens is the same as 100, and then the extra 4 tens. And then that 100 that I get adds to the 9 or the 800s that I already had, and I get 941. So both of these algorithms work just the same. The only difference is that in one, or in the more compact version of the algorithm, we regroup as we go. Whereas in this version, we regroup at the end. So notice that the only real difference is how much space these take up. This one takes up a little bit more space on paper. Well, as children are first exposed to the algorithms for addition and subtraction, we need to stop caring about how much space these things take up and worry about whether or not students understand what's going on. Very few students can explain this regrouping, so it's nice to kind of spread it out into a longer algorithm that we then add together at the end. So let's look at some place value diagrams, and by that we mean a diagram that shows 100 as a flat, or one of these, and let's see if I've got some tens and ones around here. Here's some ones. And the tens. Let's see, where are all my tens? Sorry, a little technical difficulty. I'm gonna get my tens and ones out here. Here's the tens. Okay? So these are actual place value blocks, which we can support students to use, just like Ms. Ludington was saying, that the manipulatives really help because they can measure out. It takes 10 little ones to build a 10, and then it takes 10 hundred or 10 tens, get repackaged into what we call a flat or a 100. So I'm going to put these aside and I'm going to say, what if we just drew it? So 894 would be 100, 2, 3. Now I'm up to 400s, 5, 6, 7, 800s, and 94. So I'm going to do 1, 2, 3, 4, 5 tens. 1, 2, 3, 4 tens. So there's my 894. And then to add 47 to that, I'm going to think of adding 1, 2, 3, 4, and 7 ones. 1, 2, 3, 4, 5, 6, 7. So there's my 4 tens and 7 ones for 47. Now let's think about how many do I have in all? Well, all together I have 11 ones, which is the same as one new group of 10. So I'm going to cross this out and make a new group of 10. And then I have 1, 1. And then how many tens do I have? Well, I have 5, 6, 7, 8, 9. And then I can take this one. And now I have enough to package these together into a new 100. And then what's left over is 4. So I have 1, 1, 4 tens. And then how many hundreds do I have? Well, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 hundreds. So thinking about how this works, let's take a look. When we regroup at the end, it looks like this, saying, well, how many do we have? We have 11 ones, 14 tens, and 8 100s. Right, that's what we got here. Or 13 tens, sorry, 13 tens. Which is how many we had before I regrouped. I had 11 ones, 13 tens, and 8 100s. And then after that, I regrouped them. So I figured out how many tens is that in all. Well, one of them turns into these. Whereas if I regroup as I go, that's what we were doing a second ago, where I cross them out, move them over, cross them out, move them over. Okay? So in both cases, we get the same thing. So the next question asks us to solve 777 plus 69 using both methods. So if I were to do this with the old faithful standard algorithm that you're probably used to, I would get 6 ones, and I would actually get 16 ones. Actually, I'm going to do the expanded version first. So I get 16 ones. How many tens do I have? Well, I have 7 tens and 6 tens. Makes 13 tens, or 130. 13 tens. And how many hundreds? Well, I just have 7 100s. If I add all those up, I get 6 ones, 4 tens, and 8 100s. And I could defend that by showing that if I have 7 tens, hundreds, sorry, and 7 tens, 1, 2, 3, 4, 5, 6, 7, and 7 ones, and I add to that 9 ones, 3, 4, 5, 6, 7, 8, 9, and 6 tens, 1, 2, 3, 4, 5, 6. But all together, first I'm going to count all of these pieces up. So that gives me 16 ones, 13 tens, or 130, and 700. And then I could think about regrouping after that. So in the end, I'm going to have 6 ones, 4 tens, and 8 hundreds. And I'll show the regrouping as I go now. I'm going to do the other strategy. So if I do it the way that saves more paper, but doesn't necessarily show us how the strategy works. 7 plus 9 is 16 ones. So it's like I'm immediately taking, here's 5, 10. So it's like before I go any further, it's figuring out how many will I have left over when I repackage them. Well, I'm gonna have 6, so I put my 6 ones down. And since I know I'm not gonna get any extra ones from over here, I can go ahead and write 6 ones. And then now, these guys, these 10, now count in the tens place. So I add a 10. Now I'm gonna package these together. So 5, 6, 7, 8, 9, 10. So these 10 tens can now turn into 1 100. So, and then how many am I gonna have left? 1, 2, 3, 4. So I have 4 tens. I know I'm not gonna get any extra tens anywhere else, so I can go ahead and put 4 down as my final number of tens. But these other 10 tens, I recognize that those are 100, so I'm gonna add 1 to the hundreds column, and then I get 800. So the only real difference in these two strategies is that one honors place value, because students aren't trained to see 7 plus 6 is 13, but rather 7 tens plus 6 tens is 13 tens. And it helps children learn to honor place value. So when we think about the advantage of the compact version, well, it takes less paper, and it's maybe a little more familiar to you as a practicing teacher. However, that's not really a good enough excuse, because the advantages of the expanded version is it reminds us how much each of these place values is worth. That 6 tens and 7 tens is not 13, but 13 tens, or 130. Okay, but one of the things I want you to recognize is that in both cases, defending our answer with place value blocks can really try to make the math show through what's going on. All right, I hope this was helpful. You should still have some writing to do for part A and part D, and we will see you in class. Bye-bye.